All right, Mr. Trutna here. This is worksheet C from Unit 3. Right now we are on page, let's see, what page are we on? I don't even know. So if I went back there, we're on page 1, 2, 3, 4. We're on page 5. So what we're going to do is I'm going to do a couple of the problems on this worksheet here. We've done a lot of them already. They've been submitted in the Google Classroom, and we'll just do a couple more. Okay, so in number 3, we are given that angle BAC is congruent to angle DEC. That's our first given. Our second given is C is the midpoint of line segment AE. And we're going to prove that triangle ABC is congruent to triangle EDC. Okay, so triangle ABC would be this triangle right here. And as you've noticed that when I'm doing these problems, I like to color in the two triangles that I'm proving congruent. And the reason why I like to do that is it gives me a visual of what I'm going to show is congruent. Okay, so that's the idea there, is I'm going to prove that those two triangles there are congruent. The orange one is congruent to the green one. All right, so remember our strategy is we go to our given, and our first given we're going to write as our very first statement. So statement number 1 is angle BAC is congruent to angle DEC. And the reason for that first statement is that what information was given to us. So we write given. Okay, then I'm going to go to my picture or my diagram, and I'm going to mark that those two angles are congruent. So angle BAC, start at B, to mark it, follow it to A, and where it takes a turn for C, that's the angle. So that angle right there, I'll do it in black marker, it'd probably be easier to see. So we're saying that angle BAC is congruent to angle GEC. So to mark angle GEC, start at D, go to E, take a turn, right where you take the turn on the way to C, that's the angle right there. So we're saying that those two angles are congruent to each other. Okay, now my second given is what I would write in my second statement. C is the midpoint of line segment AE. And once again, that reason for that statement is given. It was given to me right here. All right, now, as we've talked about in this previous videos and also in class, if you don't specifically say something that's congruent, like we didn't specifically say anything's congruent in statement number 2, then we don't go up to our diagram and we don't make any congruent marks to show that they're congruent. But many times, if you don't specifically say something's congruent, there is a key definition word that tells you, that's going to lead you to find congruent pieces. So you can see we're told that C is the midpoint of line segment AE. So there is C, and here is line segment AE going that way. So a midpoint, what it does is a midpoint will create two equal sides. And the two equal sides, because C is the midpoint, would be side A to C, and it would be congruent to side E to C. Okay, and what we're using here is the reason why those are congruent is the definition of midpoint. All right. So there we go, and then we just said that two pieces were congruent, so we're going to mark that side A to C is congruent to side E to C with the tick mark. Okay, and then you can see up here that I have no more information that I can get from my givens. I've used up all my givens. Okay, but from my diagram, I don't have enough information yet to determine or to definitively state or to prove that the two triangles are congruent. All right, so what I have to do is I have to use my understanding of geometrical terms to find something else in the diagram that absolutely has to be congruent. And you should notice that these two angles right here have to be congruent because they're vertical angles, and vertical angles are always congruent. So my statement number 4 is going to state that these two vertical angles are congruent. So this vertical angle can be called angle ACB. So I'm going to say, put the angle symbol, and then go ACB, and then that is congruent to angle, and the way to name this angle over here, I could call it angle ECD. All right, so those two angles would be congruent, and my reason is because of vertical angles. All right, now be very careful going back to naming the angles. When you name these two vertical angles, you can't just call them angle C and angle C. Okay, you have to be as specific as possible. If I just say angle C, I'm not too sure if you're talking about that angle, or heck, you could be talking about this angle here or that angle up there. So, but when you say angle ACB, you are specifically saying it has to be that angle. Now, if you notice, I now have enough information to determine if the triangles are congruent. So my last statement is going to be what I'm trying to prove. So I'm going to write triangle ACB is congruent to triangle EDC. And my reason for that is going to be, notice I have two angles that are congruent. I have a side that's in between the two angles, so that reason would be angle, side, angle. So that would be how you do page 5, number 3. All right, so now I'm going to spend some time going over the last page, which would be page 7, or the last page that actually has problems on it. And I'll go ahead and do the first 6 problems, and then leave it up to you to finish numbers 7 through 12. Okay, so the directions say we're going to compare the triangles and determine whether they can be proven congruent, if possible, by side, 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 angle, side, angle, side, angle, 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 side, or HL. Okay, then we're going to write our answer in the box. All right, okay, so number 1. So what we do in this is we look at the marks and we see what's given to us. So we're told that that angle is the same as that angle, so I have an A. We are told that that angle is the same as that angle in the two triangles, so I have another A, and that's all the information that is given to me by the marks. All right, so what we have to do is we have to find more information that's congruent, and if you should notice that this line right here is equal to itself in both triangles. So I have an A, and then I have a side. Okay, so now what rule works with two A's and an S? Well, it could be angle, side, angle, or it could be angle, angle, side. All right, and it depends where the side is. Is the side, since the side is in between the two angles, as you can see from your picture, number 1 has to be angle, side, angle. Angle, side, angle means you have two sets of equal angles, you have one set of equal sides, and the side is in between the two angles. Moving on to number 2, if you notice, I'm comparing these two triangles. I have those tick marks here. That tells me that this side is congruent to this side, so I have an S. I have these double tick marks here, so this tells me that the top side is congruent to the bottom side, so I have another S. And based on the given marks, that's all that I have. So once again, I need to find another piece that's congruent. And this side right here, if you notice, it's equal to itself on both sides. So I have 3 S's, so number 2, the triangles would be congruent, and my reason would be side, side, side. Moving on to number 3. Let's write down over here what we notice is the same. So if you notice, the angle in the triangle on the left, that angle is marked as the angle in the triangle on the right, so that's an A. I have another set of angles that are equal here, so I have another A, and then I have that S. I have those sides which are marked as equal, so I have an S. So once again, in number 3, much like number 1, I have 2 A's that are equal, 2 sets of equal angles in each triangle, and I have 1 set of equal sides, or congruent sides. So now the question is it ASA or is it AAS? Okay, well, let's look at the side. That side is opposite the 2 angles, so that means number 3 has to be angle, angle, side.